Right, so this piece of mathematics is called the K method, or I call it the K method. Most other students like to refer to it as fish, and you'll see why as we go along. So let's start by considering a simple situation like three identical books cost £48, so how much would 10 of them cost? Well, you already know how to do this. The idea would be to take it down to one book first of all. So let's divide that relationship by 3, so I know that one book is £16, and then multiply by 10, I know that it's £160. So really easy. And this is one of the situations in maths where wordy questions are actually easier than when there isn't words. Typically, you're normally of the opinion that when you have wordy things, that makes it harder. But actually, the context helps us to do it. The fact that I know they're books and it's money actually gives us the clue that times and divide is all we need to do, and it's obvious how to lay it out because you're very familiar with the idea of books and money and so on. The following situation is actually exactly the same question, but written in a very, very different way. Now that is actually exactly the same as that. Maybe I'll put them both on the screen at the same time. These are identical questions, and you would do very similar methods. But down here, there's no context at all, just algebra, and people typically would find this question a lot harder down here than this one up here. But really, it's the same. It's a direct proportion question, and the answers are the same as well. So down here, the y represents the total cost and the x represents the number of books. So we're saying the total cost is 48 when you're buying 3 books. Find the total cost when you're buying 10 books. So as soon as you give them their meanings, that x is the number of books and y is the total cost, then it becomes a bit easier. But we're not going to do any costings. We're just going to work with the algebra and do a purely algebraic method. This is called the K method. When you see the phrase is directly proportional to, you can replace that with one of two things. Is directly proportional to can be written as fish, it's actually a Greek letter, alpha, or more usefully can be written like this, equals k multiplied by. So I'll say that again slowly. The English phrase is directly proportional to could instead be written with that mathematical symbol, so you can replace all of that English with that symbol, or the more useful one is you can replace all of this English with equals k multiplied by. Let's show you how this works and why it's useful. So y is directly proportional to, well, that can be written as y is directly proportional to x. Okay, y is directly proportional to x. I've written the same thing. This is in English, but this is with the other relationship instead, using the mathematical symbol instead. And this is why students typically call this topic, oh, it's fish, it's the thing with fish. Okay, let's go on. Although that's a true mathematical statement, it does absolutely nothing for us. It's not useful in any way other than you're supposed to know what that symbol means. So they could literally set you a question which requires you to interpret this symbol. You will see some later on as we go along, but there's nothing you really do with it. So the K method, you don't even need that to begin with. Let's do the other one. Y is directly proportional to x. That can be written as y is directly proportional to x. And so that equals k multiplied by was instead of the is directly proportional to. So all I've done is I've turned this English sentence into an equation. Y is directly proportional to x. The next step is to try to figure out what some of these things are. So they're telling us that y is 48 when x is 3. If I put those numbers in there, I should be able to work out what k is, because literally at the moment I'm told that the connection between x and y is that to get y you multiply it by some mystery number k. Well, if I put these numbers in, I should be able to work out what k is. So y is 48 when k is 3. So I've done nothing more complicated than replace y with 48 and x with 3. That's all I've done. You can rewrite that if you want to as 48 equals 3k. K times 3 is 3k. But I'm trying to figure out what k is. To get k on its own, I'll need to undo this multiplication by 3. So let's divide both sides by 3. I'll save you the effort. 48 divided by 3 is 16. So my k is 16. What you then do is put this back into the original equation. So this k equals 16. Put it back into here, because when you first wrote this statement, you were saying the relationship between x and y is that y is some mystery number times by x. But better that, you now know that it's not some mystery number, it's 16 times x. So that is actually the proper connection between the y and the x in the whole question. I can now use this for anything else that I want. So this one here is now easy. Find y when x equals 10. Easy peasy. I just substitute x equals 10 into this equation here. So y equals 16 times 10. And I know that 16 times 10 is 160. And I'm done. And I hope you can see now how that really was the same question as the one with the books. But there is absolutely no need to invent a context for these. If a question is straightforwardly given in just algebra, you can change this English into this algebra and then just substitute what you know and away you go. I'm going to show you a few more examples because you wouldn't normally get it from just one example. And similarly, me just saying the same thing over and over again won't help either. So let's look at another example. So in this one, I've got that A is proportional to L. Recall, this was what I said earlier. It doesn't need to say the word directly. It normally does, but it doesn't have to. It could just say is proportional to. It doesn't need to have the word directly. But it's still the same question. Don't let that confuse you. So I can, if I want to, write this as A is directly proportional to L. There's no point. You can even skip that if you want to, because it doesn't help us in any way, but you're supposed to know that that little fish symbol means is proportional to. Where it's really useful though is the other one, the equals k thing. So I'm going to write that A is directly proportional to L. Alright, you can write that as KL without the times sign if you like. So what I know then is that the relationship between A and L is that to get A, you just multiply L by some mystery number. If I put these in for the A and the L, I should be able to work out what the mystery number is. So let's put that A is 42 when L is 7. So I've replaced the L with 7 and the A with 42. The opposite of times by 7 is divide by 7. That's how I'll get K on its own. So divide both sides by 7. That's just 6. And so now I know that k is 6, I can put it back into here. And so originally I was saying that you multiply L by a mystery number to get A, but now I know that actually the mystery number is just 6. So the actual relationship between A and L is actually A equals 6L. Notice how I've just done all of that work before I even read the question, and that's quite an important point. When you've got a K-method question, that sounds strange, doesn't it? Because I would normally encourage you to read the question and still read the question. But when you've got a K-method question, you start dealing with all of this stuff before you go ahead and use it and do the question. So I've turned that sentence into this equation. I put these numbers in and I figured out that k is 6, so I actually know a proper equation now without a mystery number in there, without a k. Now I can start doing the question because I'm going to use that in parts A and B. So in A, I know that A is 6L. Let's just substitute L is 9 into here. 6 times 9 is 54, so I get that A is 54. Really easy. In the same kind of way, I'll start with the relationship A equals 6L. I know this time that A is 240, and I want to work out what L is, so let's divide both sides by 6. What's that going to give me? 40? Yeah, 6 fours are 24, so that's 40, isn't it? L is 40. So I worked out all of this stuff. I worked out that equation there before I even did the question. Another thing to point out at this stage is you're not permitted to just do these in your head. For the very early questions, some of you will just look at that and say, oh, well, obviously that you times that by 6 to get that, so I just times that by 6, I just divide that by 6. Great if you can, great if your times tables are strong enough that you recognize those relationships, but it's not allowed. Questions that look like this will only score full marks when you've produced the method they're expecting. I'll do one more of these direct proportion ones with you that uses the same kind of relationship, but I'll go a bit quicker now. So I can write this as y is proportional to x, but feel free to skip that because it doesn't do anything anyway. Where it's really useful is the other one, and so I can say that y is directly proportional to x. Feel free to write that without the times sign. You can just call it kx if you want to. Let's put the 2 and the 21 in. Notice the slightly different English here, but I can still go ahead and do it. So x is 2, y is 21. If I divide both sides by 2, I get 10.5 is my k. Now I know what k is. It goes back into here, and make sure you write all of these stages. So that's actually the relationship I need to do this question. Find x when y equals 50. So I'm going to write that y equals 10.5x. Let's sub in what I know. Y is 50. So 50 equals 10.5 times x. And I'll now divide both sides by 10.5. Might need a calculator for this. Instinct is that might not be a very nice number, but we shall see. 50 divided by, oh, you're in shadow, sorry. 50 divided by 10.5. I think the fraction is nicer there. So let's call that 100 over 21. I think that's a nicer number than the decimal equivalent. Notice how there's no particular reason to expect nice numbers. Don't very often get negatives with these, but you could have fractions, decimals all over the place. So just suck it up, I'm afraid. Okay, some examples that contain squares then, but the method is exactly the same. So you can write a is proportional to d squared if you want to, although that doesn't actually do anything. More useful would be if you use the other one, y equals k multiplied by d squared. Feel free to write that without the times sign. You can just call it a equals k d squared if you want to. Now you need to be a bit careful with BIDMAS here. There is a common mistake people do. So let's substitute these in, and I'll talk about that mistake in a moment. So when a is 320, you've got that d is 4. I'm going to have to do this, do the powers first, right? So 4 squared is 16. Maybe you wouldn't have made a mistake there, but lots of people would. That's 16. Now I can divide both sides by 16. It's not divide by 4, you see. So let's divide both sides by 16. And 320 divided by 16, I believe to be 20. Now I know that k is 20, it can go back into here, and so it's not really a equals a mystery number times d squared, it's a equals 20 times d squared. Again, write it with or without the times sign. In this question, I want to find a when d is 5, so let's put my relationship up here again. A is 20d squared. Let's put 5 in there. A equals 20 times 5 squared. Again, BIDMAS, this here is not do 20 times 5 first and then square the 100. It's square the 5 first. So that's 20 times 25. 2 25s will be 50, so it gives us 500. So 500, not 1,000. Be careful with your BIDMAS. This one has a little bit more English, but it's the same idea again. So I can write this, if I want to, as y is proportional to, the cube of x is normally written as x cubed, like that. But that's not the most useful relationship in the world. Let's go with the other one, k multiplied by x cubed. That can be written without the times sign if you like. Let's substitute what I know. So I know that y is 54 when x is 3. So let's put 3 in here. Don't forget the cube sign goes with it. Okay, 3 cubed is 27. So that says k times 27 when you do the powers first, doing the BIDMAS. To get k on its own, I need to undo the fact that it's currently multiplied by 27. So let's divide both sides by 27. That gives us 2. K is just nice, easy 2. So that goes in there. At the beginning, I was writing that the relationship is y equals some mystery number times x cubed, but actually I know that mystery number now is just 2. So that is our nice, easy relationship. Notice how I've done all of that work before even looking at the question, but the A and the B. So let's use it. When I'm doing A, I start by writing the equation that I've just found, or the formula that I've just found. What do I know? Find y when x is 4. Okay, let's just put 4 in here then. Again, careful, this is BIDMAS. 4 cubed is 64, and 2 times 64 is 128. Part B, in the same way, y equals 2x cubed. Let's substitute what we know. We know this time that y is 2000. I want x on its own, but x has been cubed and multiplied by 2. The opposite of times by 2 is divide by 2. So let's divide both sides by 2. And the opposite of cubing is actually cube rooting. So I can write that I'm doing that before I actually do it, if you like. Let's cube root all of this, because that undoes the cubing. And the cube root of 1000 is just 10. So x equals 10. So this question has a new word, the word inversely. When you see inversely proportional to, the relationship is slightly different. So rather than writing just the fish, there's an extra bit, and I'll show you how that works in a minute. But rather than k multiplied by, it should be k divided by. Okay, so that whole phrase is inversely proportional to, should be written as equals k divided by. Okay, let's have a go and use that relationship. So y is inversely proportional to x. If you want to use the fish, you'd be writing y is inversely proportional to x, like that. So you make it like a fraction, basically. But don't worry, don't even care about that one. It's not important. Feel free to skip it. It's the other one that's more important. So y is inversely proportional to x. All right, so what I've done there is I've just rewritten is inversely proportional to as equals k divided by, the y is on the left, x is underneath, like so. So y is inversely proportional to x, like so. Okay, so at the moment I know the relationship between y and x is a mystery number divided by, but if I put these in, I can work out the mystery number. So when y is 9, x is 4. To get k on its own here, this says k divided by 4, so to get k on its own I need to multiply both sides by 4. So multiply this by 4, I get 36, multiply this by 4, I get k on its own. I can now put that back into here, so it's no longer y equals a mystery number divided by x, it's actually y equals 36 divided by x. So I know the formula for the rest of the question. Again, notice how I started doing the question before I even read what it was asking us to do, because these typically will require you to make an equation. You can't just look at it and write it down and expect to score all the marks. Even if you can just look at it and write it down, you won't score all the marks. Okay, so find y when x is 12. So I'll start by writing the formula, then substitute what I know. X is 12. And 36 divided by 12 is 3. So I'm done. Y is 3. Let's do another one. So I've got that P is inversely proportional to Q. There's a couple of questions, but we'll start dealing with this before I even read them. So P is inversely proportional to Q. No one really cares about that though. What I do care about is P is inversely proportional to Q, like so. Now let's substitute what I know to try working out what the k is. If q is 8, p is 15. Okay, p is 15 if q is 8. To get k on its own, I need to multiply both sides by 8 there, don't I? So it's times by 8. 15 times 8 is, well, if I double it, 30, double it, it's 120, I reckon. That's always a way of multiplying by 8 in your head, is you can double it, and double it again. So I now know that k is 120. So let's stick that in here. Originally I was writing that p is some mystery number divided by q, but actually I've now worked out that p is 120 divided by q. And that's what I will use for the rest of the question. So when I do part A, which I still haven't read yet, I'll start by writing p equals 120 over q. Great. Now let's do it. Find q when p is 24. Nothing harder than making p 24. Actually, maybe it's a little bit harder. Let's put p as 24 in here. So 24 equals 120 over q. I'm not mad keen on dividing by q, so I would say the opposite of dividing by q is multiplying by q. Let's multiply both sides by q. If I multiply the left by q, I get 24q. If I multiply the right by q, I just get 120. That was the whole point of multiplying by q, was to get rid of the divide by q. I want q on its own, but at the moment q has been multiplied by 24, so let's divide both sides by 24, and 120 divided by 24 is 5, isn't it? I think q is, 5 24s gives us, 5 24s gives 120, so that's the correct answer. But notice again how it was just you write the thing down and then you substitute what you know. There might be a bit of work to do afterwards, but that's just solving an equation. That's not really anything to do with K-method. The K-method question finished when you were here. And that's got nothing to do with the K-method down here. That's just solving an equation. Part B, P equals 120 over Q. Let's do it. I know that Q is 20. So P equals 120 over 20. Great, that's just the same as 12 divided by 2. That is 6. P equals 6. Now, there's absolutely no reason why you can't have a mixture of things. So earlier on I showed you what if it's got squares in it, and then I showed you what if it's inverse. Well, you could have both things going on in the same question. There's no reason why not. So G is inversely proportional to the square of D. G is inversely proportional to the square of D. I'm not going to worry too much about that. So square of D can be written as D squared, can't it? And is inversely proportional to is written as equals K divided by. So let's do that. G equals K divided by the square of D, D squared. Let's substitute what I know. So G is 20 when D is 2. Don't forget there's a squared on there. D squared. D squared. D is 2, so 2 squared. Let's do my powers first. So 2 squared is 4. And to get K on its own, the opposite of divide by 4 is times by 4. Multiply both sides by 4, that gives us 80. So I now know that K is 80, and that can go back into here because my original statement was saying that G is some mystery number divided by G squared, but actually the mystery number is 80. So it's G equals 80 over D squared. Great, that's the formula that I need. And now I'm going to use it. So find G when D is 4. G equals 80 over D squared. Let's just substitute the D is 4. So G equals 80 over 4 squared. Again, don't forget the squared sign. Lots of people do at this stage. 4 squared is 16. And 80 divided by 16 is 5. So I'm done that G is 5 when D is 4. Finally, you can have all sorts of things going on. Why not? X is proportional to the square root of Y. Okay, no reason why not. Now I'm back to direct proportion here. Did you notice it doesn't say the word direct, but it doesn't say inverse either. And recall, if it doesn't say one, it's direct. All right, so it can either have the word direct or not, but if it doesn't have it, it is direct proportion. It's the K multiplied by situation again. If it's going to be inverse, they must say inverse. Otherwise, we assume direct. So X is proportional to the square root of Y. Or the square root of Y, that can be written as like we call this a radical. You can put it in a little house, kind of like a surd. Oh, sorry, I'm off the edge of the page. Little surd type thing. So if I want to write X is directly proportional to the square root of Y, I can say X is directly proportional to the square root of Y, although that's not hugely useful. X is directly proportional to the square root of Y. Recall, when it's direct proportion, it's multiply. Let's substitute what we know. So we know that when X is 50, I've got that Y is 25. you do square roots at the same time you would do powers, because it is a power effectively, power half, isn't it? So the square root of 25 is 5. I'm just going to carry on down here. If 50 equals k times 5, and so the only thing k could be there is 10, isn't it? Divide both sides by 5. 10 is your k. So I can put that back into here. So originally I was saying that x is some mystery number times by the square root of y, but actually I know that it's x equals 10 times the square root of y. That is actually the formula I need to use for the rest of the question. So part A, let's write it. X equals 10 root y. Find x when y equals 900. Okay, let's just put 900 in here then. The square root of 900 is 30, and 10 times 30 is 300. And I've done that bit. For part B, so let's substitute what we know. We've got that x is 640 equals 10 root y. I can divide both sides by 10 to get that 64 is the square root of y. And be careful, don't square root this again. Don't say the answer is 8 or minus 8 or something like that. To finish this off, to get y on its own, you need to square both sides. I'll use my calculator to help me there. So 64 squared is 4096. And I'm done.